Hi there, this is your learning facilitator in Earth Science Grade 11, Mom M. Magdadaro. Welcome back to another week of learning. It's a brand new day to discover a lot of things in Earth Science Grade 11. We are now in week 5, lesson 9 and lesson 10. So in lesson 9, we are discussing the various water resources on Earth. So what are the different sources of water we have around us? So we define water as a marvelous substance which can be beautiful, powerful, and destructive in the sense that in time it could also take our lives and it could also give life at the same time. Now water is very unique because of its different forms. Okay, it could exist in 3 states, the liquid, solid, and gas, which make it very useful in different. Now, water is widely distributed all throughout the different phases of the Earth because of this hydrologic cycle or its cycle. The hydrologic cycle is the continuous movement of water on, above, and even underneath the surface of the Earth. And because of this, water could be found in different forms. And we know that the Earth is covered with 71% of water, and this is widely distributed all throughout the faces of the Earth. And we have here like from the ocean, we have also the glaciers and ice caps, the groundwater, the fresh water that we have, okay, the lakes, and the other forms of it. Now in the oceans, we know that the ocean contains actually 97% of the Earth's water. It's the largest, okay, the largest area and volume of water we have, and it can contain the average of 35 grams of salt per liter and could be used in so many ways once it is desalinated. And the ice and snow could also contain 99% of fresh water and is as much 2 kilometers thick, and it could situate in most of the areas from Antarctica, Greenland, and other snow mountains. The next one is the groundwater. The groundwater is coming from the rock and soil layer beneath the Earth's surface, and this is from the absorbed excess runoff, rain, and snow on ground, which will eventually return to lakes, streams, rivers, or marshes, and afterwards will be readily available for use. And we also have these wetlands and soil moisture. So wetlands are areas of land where water covers the surface for at least part of the year, and they are not as important as lakes and rivers to water storage. However, they play a vital role in some erosion protection, flood reduction, groundwater replenishment, and trapping nutrient sediment, and even water purification and providing fish and wildlife habitat. And another distribution of water we have is in the atmosphere. So the atmosphere contains about 0.001% of the Earth's water, and it's around 4% of the volume in the atmosphere is comprised of water. So movement of water through the atmosphere provides, okay, a very important significance in the mechanism of distributing fresh water to terrestrial reservoir in form like the rain or snow or hail that fall to the. Now, according to UN, we have these types of water uses. So in the world water use, they consider this percentage wherein the irrigation has the highest consumption, followed by the industrial use of water, and the last one is the domestic use of water in our different homes. So we also have these offstream uses of water. Could refer to the agricultural use, thermoelectric use, industrial mining, domestic, and commercial use. So what are these agricultural, thermoelectric, industrial mining, and domestic commercial? Now we have these different uses in agriculture. As you see in the picture, they use it for flood irrigation, sprinkler irrigation, and drip irrigation, all for the benefit of our farmers in the absence of rain. So they have this what we call um, method for the crops to survive with the use of the irrigational system. And another use in the agriculture is also in the livestock. Okay, so like when we are watering the livestock, some dairy operation, cleaning them, cooling livestock facilities, or dairy sanitations and clean up, and the animal waste disposal, all with the use of water. And another one in agriculture also, okay, specifically in aquaculture, like in raising some fish, raising shellfish, raising shrimp and lobster, and raising other creatures living in water. And of course, in thermoelectric, the water is used in production of electrical power because of the different sources of water we have. We have the source of electricity. Now, it is one of the largest use in water in the US and probably also in the Philippines. This also has wide use for the production of electricity in different homes and establishments. So in 2005, it consumed about like 201,000 million gallons of water each day. So that's how big the consumption is. So thermoelectric occupied 40% of the total water use in the US. That's how big it is. And also another use of water is for the industrial use. Now in the industries, need water to cool down their machinery to a temperature that allows the manufacturing process to keep going. So sometimes when they take a break and need to cool off their machines, they need or use this water. And water also is needed to clean, of course, the machinery and the products and the buildings at the same time for some maintenance. And another is the industries also need water. That's why during the survey, okay, the diagram that I showed a while ago, industrial use has the biggest consumption of water. Another use of water is in mining. So water is used for the extraction of minerals that can be in forms of solid, like coal, the iron, gold, and sand. For liquid, also the crude oil, and for gas, the natural gases. So when they extract some minerals, they use these different forms. As I mentioned a while ago, that out from the uniqueness of water, we can use it in different forms. So this is one of the best example in mining. When they try to extract minerals, they can use the solid form of water to extract coal and iron, gold, and sand. And also they use this liquid form for crude oil and the gas form of water for the natural gases. And of course, the very common use of water is the domestic use in our household or different homes. Now, domestic water use in the consumption for household purposes, both indoor and outdoor. We know that inside and outside our houses, we use water significantly every day. The next one is the commercial use of water. Okay, used in some businesses such as the hotels, restaurants, marketplaces, and so on. Now, in the Philippines, we know, particularly in the Tagaytay district, okay, the highest consumption of water also goes to establishments, especially, or some businesses, especially before the pandemic. Okay, we have a lot of restaurants here, some hotels that really has the highest consumption of water every day. Anyway, that is why in some of the areas, affected areas, we have this what we call water shortage, wherein we can only use water in a scheduled basis. Another is the in-stream uses. So in in-stream uses, we have the hydropower use, the recreational use, the ecosystem support, and the navigation support. So that's why we call it in-stream use. Still, we use water in different ways. Even if during our recreation time, yeah, we use water. And navigation means like when we travel, we use water, we use the sea. And then the ecosystem support also at the same time use water. And the hydropower that we use, the reservoir that we use. Next one are the sources of water. Now, specifically we're discussing about the different sources of water that we have. So we have the subdivision of the source of water into surface water and groundwater. So referring to the surface water, we have the lakes, the ponds, the streams, the rivers, the storage reservoir. And the groundwater underneath the surface of the earth could represent the open wells, the tube wells, the artisan wells, the different wells, and the springs and the infiltration. The different sources of water in the surface of the earth are the following. We have the lake, the ponds, the streams, and the river. So the surface water is the water in the surface on the planets, such as these river, lake, wetland, or ocean, that can be contrasted with groundwater and atmospheric water. So non-saline water is replenished by precipitation, okay, during the water cycle, and by recruitment from the ground. So they're collected, and it's also lost through evaporation and becomes groundwater, which are used by plants for transpiration extracted by mankind, agriculture, living industry, and other discharge to sea, where it becomes saline water. So the first two examples of the surface water are the lake and the ponds. So lakes are inland bodies of standing water, and this can be formed by glaciers or tectonic plates movement. Once there was a movement, and would eventually lead to movement of one plate to another, so rivers and some lakes will be created. And the quantity of water in the lakes depends on its basin capacity, okay, the catchment area every day for the rainfall and porosity of ground. And millions of lakes are settled over the earth's surface, and most are located in the higher latitudes and mountains areas. So the Great Lakes of the United States and Canada are the world's largest system of the fresh water that we have. And another one is the pond. So a pond is a body of standing water, either natural or artificial. So this could also be natural or man-made at the same time. That is usually smaller than the lake. So it's still stagnant, but just smaller than the lake. Okay, they may be arising naturally from floodplains and a part of the river system. So sometimes when they lead to a certain area where they could be gathered, it will create ponds eventually. And the rainwater is another source of water in the surface of the earth. So rain is a major component of water cycle. Yeah, we know that it's responsible for depositing most of the fresh water on the earth. So water vapor, okay, condenses and returns to earth as precipitations, once again replenishing the reservoir, the lakes, the rivers, and other sources of water that were lost. So lost during the evaporation. So much of the rain that enters the ground filters down into a subsurface water, okay, and eventually reaches the lakes, the streams, and the rivers. Okay, so that's one of our sources of water in the surface of the earth. So during the water cycle, when there is precipitation and rain, it will be added to the different bodies of water we have in the surface of the earth. And the other one is impounded reservoir. So this reservoir that we make is an enlarged natural, could be also artificial lake, okay, storage, where we could use them during the time when there is scarcity of water supply. So it's also known as the storage reservoir. And another source of water in the surface of the earth is the spring. So springs typically are present where the water table intersects the land surface. So spring is present, and it can discharge fresh groundwater either onto the ground surface, directly into the beds of rivers or streams, or directly into the oceans below the sea level. And some also sources of water in the surface of the earth are the infiltration galleries. So the groundwater while traveling can be obstructed by digging a trench or by constructing a tunnel with holes outside at right angle. So this will create actually some areas wherein the water could be preserved. So this is already part of the the source of water from the ground. Now another is rivers and streams. So rivers and streams are the bodies of flowing surface water driven by gravity. So they come from a higher place going down, and naturally eventually will lead them to the largest part of the water, which is the ocean. Now, the difference of stream and river, when we say stream, is a small channel along which water is continuously flowing down a slopey area. Okay, yes, it's just quite small when we say stream, but when you say river, it's a large channel along which the water is continually also flowing down to a slopey area. Okay, and all rivers and streams start at some high point, and the highest point can be a mountain and hill or another elevated area. Okay, so they come from higher places and they go down, they find their way out going down. So talking about groundwater as one of our sources of water, so it's the water present beneath the surface of the earth, in soil, pore spaces, and in the fractures of rock formations. So they could be described in the following. You have the open wells, the tube wells, the artisan wells, and the infiltration. So one of the common examples of the source of water in groundwater are the driven well and dug well. So driven well are much more common in today's society. So there are dug wells that are created with small pipe only, driven into the ground, and the pipe has a filter over the bottom to keep out as much as sediment as possible during the process. So once the well is deep enough, all of the dirt is washed out on the inside of the pipe, and pumped is installed so that water can be removed from the well. And also we have the dug well. So the dug wells have large diameter and expose a large area to a qualifier aquifer, and this well is able to obtain water from less permeable materials such as very fine sand, silt, or clay. Another groundwater source is the infiltration well, okay, which are shallow wells which are constructed under the bed of rivers. So water infiltrates from both bottom and side. So there is only a hand pumped windmill or power pump is used to pump out water from the well. So it was also very common in our time before. So artisan well is simply a well that doesn't require a pump to bring out water from the surface to the surface. So this occurs when there is enough surface in the aquifer and the pressure forces the water to the surface without any sort of assistance. So the aquifer is the geologic layer of permeable and porous rock such as sandstone or limestone, and that provides the water source for the artisan well. So that's how artisan well. Another source of water is our drinking water. When we say drinking water, it's free from pathogenic agents, free from harmful chemical factors, and some pleasure to the taste, and usable for domestic purposes. So WHO released some guidelines for drinking water quality. So we have the color, the standard should be like this, the taste and odor, turbidity, the pH level should be only 6.5 to 8.5, and the total dissolved solid. We have also the hardness of the total hardness, the chlorides, presence of chlorides, sulfates, nitrates, fluorides, calcium, and free residual chlorine, iron, manganese, and the total coliforms should be 0. Manganese should only be 0.1. So that's how we know whether that water that we drink every day is safe for us. So the sources of drinking water could be in both from the surface water and groundwater. So fresh water from the surface water, like from the streams, pond, lake, rainwater, or some impounded reservoir, and the groundwater coming from the well, the spring, porous pipe galleries, and infiltration. As we all know, water is very significant in our daily life, And if we don't conserve them today, then we might be facing a greater problem in the future. So there are some tips in order for us to save some water in our simple ways. So increasing water resources start from all of us. That's very true. So starting from our day-to-day use of water, we have to think like when there is like a waste of water, then we should stop doing it. Now we're moving on to lesson 10, week 5, lesson 10, activities that affect the quality and availability of water for human use. And before we move on to our discussion, I want you to read the song, Waste Not, Want Not. Now, upon reading this song, I want you to identify which are the phrases that are present in the song that could help in conserving the water resources. Okay, just like for example, don't leave the water running, save our lakes and river. So in the absence of water conservation, the earth could be facing different threats. Okay, so what threatens the freshwater quality? First one, when waste or other material is added when waste or other material is added to water so that it is harmful to organisms that use it or live in it. So water pollution occur. So we know already what are these activities, human activities that could lead to water pollution, like the dumping of waste in wrong way, and then no segregation of waste at the same time, that could also pollute our water, and the presence of the different chemicals in industrial establishments, okay, will lead to the different bodies of water that would contaminate it. So water pollution can be classified according to where it comes from. So point source pollution comes from one specific site, and non-point source solution comes from many small. Another threat of our freshwater quality is the thermal pollution. So it's any heating of natural water that results from human activities, such as heating of water to cool power plants. So the warm water can harm organisms that live in that water. So another is the chemical pollution. So in chemical pollution, it occurs when there is a presence of chemicals added to water supplies. And two major sources of chemical pollution are the industry and agriculture. Use of pesticides in the farms and different chemicals in the farms to preserve the crops, and at the same time the use of different chemicals in some industries sometimes be dumped anywhere that would lead to pollution to our water supply. Another is the acid rain. It's also a form of chemical pollution. So eventually acid rain is just a manifestation of how polluted our water is because of the presence of the different harmful chemicals. And another thing that threatens our freshwater quality is the biological pollution that occurs when organisms are added to water supply. So biological pollution can expose people to disease-causing microbes, and this is when we sometimes forget to treat our water, and there is already a presence of microorganisms that could. Another is the eutrophication. So this is an increase in the amount of nutrients in water. So eutrophication can be accelerated when human activity increases nutrient levels in water. Okay. So the extra nutrients cause an overgrowth of algae and can kill fish and other organisms in the water. So it's also unsafe if we sometimes exceed eutrophication. So what are these remedial measures in order for us to save our fresh water? So locate the point sources of pollution. We'll have to work against acid rain, educate our community. Let us help also rebuild our community in saving our water supply, and at the same time in maintaining the good quality of our drinking water, and ensure sustainable sewage treatment. Watch out for toxins. Be careful with what you throw away that could lead to water pollution, and use water efficiently. And you have to spread the word to everyone. Share them to everyone, to your family members, to your siblings, and to your friends who don't know how to conserve. So I'm leaving you this quote of the day: the future is in our hands. Remember that what we do today would always have a great impact or effect to the next generation. That's what I have been telling you. So water conservation for today is life conservation for tomorrow. So if we want to save the next generation, then let's start conserving our water supply and our water resources. So thank you for being with me in this another learning episode. I hope I can still be with you in our next learning lesson next week. So hoping you're doing your best in all your endeavors every day for you to complete in doing your outputs for the week. So thank you so much and have a great week ahead of you. Thank you and goodbye. So I'm leaving you this quote of the day: the future is in our hands. Remember that what we do today would always have a great impact or effect to the next generation. That's what I have been telling you. So water conservation for today is life conservation for tomorrow. So if we want to save the next generation, then let's start conserving our water supply and our water resources. So thank you for being with me in this another learning episode. I hope I could still be with you in our next learning lesson next week. So hoping you're doing your best in all your endeavors every day for you to complete in doing your outputs for the week. So thank you so much and have a great week ahead of you. Thank you and goodbye.